Right, hello there again. Let me just close the window because there's some traffic going on. Um, I kept saying that I'll come back, and yeah, today I just hopped up from my desk and said, well, no matter if I have a job or anything, let's keep this thing rolling, because a lot of times I just start too many times. I start things and I just don't go on with them, and then it becomes like just another thing that I never got to do. Anyway, I have this kettle here. I think you remember it. If not, I'll go through what happened with it again. Um, It has this lid that comes together with part of the handle, and obviously you flip the lid up, fill it with some more water, put the lid down, turn it on, wait until the water boils. Not much to it. And for some reason, for the same reason you sometimes put your suitcase in the fridge, or maybe your laptop in the washing machine and stuff like that, and I'm certain you know what I'm saying. I just because it's one of those that has a fixed base, you can't remove it from the power base. I want to buy one of those soon, but for now this is the one. Instead of unplugging it and taking it to the sink, I just fill a mug with water at the sink and then pour some water in it. And this last time, I've just repaired the LED inside that I added for cool lighting, and for some reason I forgot to pop the lid open before filling it with water. So it was like this, and I just poured water on top of it, and the LED or something inside instantly popped, and yeah, that thing worked for like a couple of days before I screwed it up again. Now I want to see what happened here. It's the first time when I have a look at it, so we'll zoom in and see it together. Let's see here. Oh wow. No, I was expecting a couple of things because obviously water is conductive, but I didn't know exactly what, because to be honest, I mean, water is conductive, but it's not that conductive. It's in the order of kilo ohms, and it's not really like a short circuit or something. So I thought maybe it changed the value of the resistor and lowered the resistance and popped the LED. By the looks of it, I think the LED is just fine. And from what I see here, I used some two enameled wires from a coil of some kind for powering up the LED, and it turns out those two wires touched together for some reason. And it shouldn't have been a problem because they're enabled. Maybe they were scratched, or I really don't have a clue. What the hell happened here? I mean, I can see what, but I don't know why. It's the first time I see something like this, so. And I want to test the LED and see if I can. I have a 3-volt battery here somewhere. Yeah. Don't know how easy it's gonna be to place it. on the LED. I want to change the color anyway because it was a blue one and I want to... There. So the LED is fine. How did this happen? Dude, I've been doing electronics and electrics since probably I remember the age of 10, probably before that. Let's just say at the age of 10. That means I have 24 years now doing stuff like this, and it's the first time I see something like this. I mean, I understand mechanical failure, like cutting through it with something, or an environment with vibration, and that these wires like vibrating against something and scraping off the enamel. And quite obviously, for this to happen, it's all plastic in here, so both of these wires must have the enamel removed in order to cause a short circuit. I I don't know what to say. Spill a bit of water here. Luckily, I'm in the kitchen. That changes things a bit. I'm gonna resolder these wires, reattach them, and I'll come back after that. Okay, it has been done. I still don't understand how that happened, but anyway, I turned the second one away from the first one and insulated them a little bit better, just to make sure that won't happen again. And now it's time for a little test. I shall plug it in. Hopefully we won't hear a loud bang. The nice flickering. I actually can see, yeah, the smoke was coming off from the heating element because, yeah, forgot about that. It has a thermal fuse though. It's not gonna be anything damaged. So I kind of tested it before shooting this with one of these 3-volt batteries, so I can see how it lights up with the water inside. I'll just reattach everything and show how it looks completely assembled. Okay, so I moved the kettle over to its normal operation spot here in the kitchen on the counter, and just put the normal amount of water I have in it, and gotta tell you, it looks pretty damn nice. And please note that the flickering is absolutely invisible with the naked eye, so you won't see that. That's actually pretty neat. I went for this, I played a bit with the positioning of the LED so I can get the best effect out of it. I think we can watch it boil now. Just to see what happens and if there's any kind of issue while it boils. And there you have it. I hope this lasts for more than a couple of days now. I'll be careful not to pour water on it again without lifting the lid first. Thanks for watching, I'll see you next time.